Hey there, I'm Nina.
And I'm Derryl.
In this video series, we're going to take a closer look at the world.
Way closer.
We're going to uncover the hidden chemical changes that are responsible for the structure and functions of all living systems and support how we live. To understand them, we have to look deep inside.
From the macroscopic to the microscopic to the molecular and even the atomic scale. Today we're taking a close look at how carbon is transformed during everyday events.
Food, fuel, plants and animals, whether they're alive or dead, all contain carbon atoms and store or use energy.
We're going to do an investigation and look a little closer to examine what's happening on a very, very tiny scale.
Right, and today we're burning ethanol. All right, let's talk about ethanol.
Ethanol. It's also known as ethyl alcohol. Ethanol is an organic material, and organic materials are made out of molecules that include carbon-carbon or carbon-hydrogen bonds. Ethanol is very flammable, but why does it burn?
We're going to investigate what happens to ethanol when it burns. Here's what we're working with: a scale that's accurate to 0.01 grams, BTB, a clear container to put over the burning ethanol, and finally, we've got ethanol to burn in a glass petri dish.
BTB doesn't stand for bad to the bone? See? I drew a little mullet on the BTB.
Derryl, what are you doing?
Sorry. BTB is bromothymol blue. BTB changes color when carbon dioxide is added, like when you blow bubbles into it.
We can use BTB to see if carbon dioxide concentrations increase in the air.
Okay, first let's make some predictions.
The predictions should be based on our answers to the three questions: the movement question,
Where are atoms moving?
the carbon question,
What is happening to the carbon atoms?
and the energy question.
What changes in energy are taking place?
So, we can use the scale to detect any mass changes. If we make some accurate predictions about changes in mass, that'll help us answer the movement question.
Because if there's a mass change, then that means atoms are going from one place to another. So, what do we think will happen after we light the ethanol? What will gain mass? What will lose mass?
Changes in BTB can help us answer the carbon question.
After 20 minutes, what kind of color changes should we expect to find in the BTB? And what would the color change tell us about what is happening to carbon atoms?
And finally, make a prediction that relates to the energy question. What forms of energy are involved? How is energy changing from one form to another?
I'm sure you have a lot of other burning questions.
Oi. Let's pause the video now as you discuss the following questions. What changes in mass will you observe? What changes in the BTB will you observe, and why? And how is this related to the movement question, the carbon question, and the energy question?
And we're back. Now let's investigate.
First, we add ethanol to the petri dish and put it on the digital scale. We're starting with 67.8 grams of ethanol.
Then we fill a petri dish with fresh, new, blue BTB right next to the ethanol.
Now, we ignite the ethanol with the lighter and then cover both petri dishes. The flame goes out pretty quickly.
After about 20 minutes, we can check for mass changes and color changes inside the container. Let's speed this up a bit.
You can see that after 20 minutes, our BTB is pretty yellow.
Now we'll measure the mass of the ethanol that's still left in the petri dish, and its mass has gone down to 66.8 grams.
We had some mass changes, and you can compare them to the mass changes from another class.
How do your results compare with those on the chart? Is there a pattern? Pause the video and discuss. So let's review. The mass of the ethanol went down, so atoms must be moving out of the ethanol and into the air. And this has to do with the movement question.
And the BTB turned yellow, so that means there was an increase in carbon dioxide concentration in the air.
Where did the carbon dioxide come from? Carbon dioxide molecules could be created in the flame, but the carbon atoms must have come from somewhere.
And finally, let's talk about energy.
What energy indicators did we see?
We had heat, light, and motion, all in the flame. And here's something else to think about. Where did the energy in the flame come from?
So now we're all fired up about carbon. This investigation was so hot. Hopefully we've sparked something new.
We'll see you next time.